Okay, so in this question, we are asked to find the derivative of the following function. Now, like in any question, we have to analyze what we have. And so, what is this function made out of? Well, I see I have a ln of something. So the natural logarithmic function of something. What is that something? It's some other function. So I can see right away that I have a nested function. So ln of some other function. So I'm going to have to apply chain rule. Now, what is this something made out of? Well, it's a fraction of two functions. Numerator is x plus 1, and the denominator is a function square root of x minus 2. So I have a quotient, so that means I'm going to have to apply quotient rule at some point in time. Now in this quotient, when I apply the quotient rule, I will have to take a derivative of the numerator, and I will have to take a derivative of the denominator, so of x plus 1 and of x square root of x minus 2. X plus 1 is not going to be an issue, but square root of x minus 2 might be an issue. So what I might want to do is first rewrite this to get rid of the square root symbol and write it in power form. So we have d over dx of ln of a fraction x plus 1, and then down in the bottom I have x minus 2 to the power of 1/2. So let's rewrite it. D over dx of ln of x plus 1 over x minus 2 to the power of 1/2. So what is that? What is the derivative of ln of something? So it's 1 over whatever that something was. So in my case, it's x plus 1 over x minus 2 to the power of 1/2. Okay. And then I have to multiply that by the derivative of the something. The something is this complex thing, which is a quotient of two functions. So let me deal with that separately. So what do I have? Oh, remember, I have a double fraction now. And so I have 1 divided by a fraction. That's the same thing as 1 times the reciprocal of that fraction, which boils down to x minus 2 to the power 1/2 divided by x plus 1. In other words, just the reciprocal. And then I have to take a derivative of the quotient. Now the quotient is going to be, I have a top and the bottom, so remember the formula. So it's the derivative of the top times the bottom minus top times derivative of the bottom divided by bottom squared. So let me copy the first part. And then let's see, what do I get when I apply the formula? My top is x plus 1. So what is the derivative of x plus 1? That's just 1. And then times the bottom. What's the bottom? It's x minus 2 to the power of 1/2. Minus top. What's my top? It's x plus 1 times the derivative of the bottom. Now what is the bottom? The bottom is x minus 2 to the power of 1/2. So it's something to the power of 1/2. So the derivative of that is 1/2 times x minus 2, that was the something, to the power of negative 1/2. And then I have to take a derivative of the inside function of x minus 2. That's just 1. And then all of that divided by my original denominator, which was x minus 2 to the power 1/2, and then all of that squared. Okay, so here's the derivative. This is the answer to our question, but that looks nasty. So we will try to simplify it. So let's copy the first part, x minus 2 to the power of 1 half divided by x plus 1, and let's try and clean up the second part. So in the numerator we have just x minus 2 to the power of 1 half, and then minus, and then I have a fraction. So what's in the fraction? I got a 2 from the 1 half. I also have x minus 2 to the power of 1 half because of that negative in the exponent. So I'm going to push it down to the denominator. And up on top I have x plus 1 times 1 times 1, which is just x plus 1. And down at the bottom, what do I have? I have square of a square root. In other words, I have exponent on exponent. So I copy the base and I multiply the exponents. So that turns out to be just x minus 2 to the power of 1. Okay, so again, remember we are trying to simplify, and I have a combination of no fraction and a fraction in the numerator. I want to put that both on the common denominator so I can have a fraction. So I'm going to copy the first part, x minus 2 to the power of 1 half over x plus 1 times, well, denominator just gets carried over. What is the common denominator between the two? Well, it is 2 times x minus 2 to the power of 1 half. So I could write it like this, but actually, you know what? Let me rewrite it in slightly different form because it might be easier to see where we are going. So I'm going to rewrite the first one. So the denominator 1 gets changed into 2 times x minus 2 to the power of 1 half. So that means on top I have x minus 2 to the power of 1 half times 2 times x minus 2 to the power of 1 half, and then minus the old one, x plus 1 over 2 times x minus 2 to the power of 1 half. Okay, I mean, it looks messier than it was before, but in fact it's going to lead us to the cleaned up part. So let's go again. Let's copy x minus 2 to the power of 1 half, and then x plus 1 times. So our thing here is, oh, I'm running out of room. So again, let me give myself a little bit of room. So in the denominator, we are going to have 2 times x minus 2 to the power of 1 half. And up in the numerator, we are going to have, oh, wait a minute. I forgot the power before. So it was x minus 2 to the power of 1 half. So when I take, it's going to be 2 times x minus 2 to the power of 1 half times x minus 2 to the power of 1 half. That's just x minus 2 to the power of 1 half plus 1 half, which is 1. In other words, square root times square root is, it's gone. And then minus all of x plus 1. That negative in front of the fraction affects both x and 1. And then on the denominator, I just have my old x minus 2, and I don't really need the bracket on it, so I'm just going to write it without the bracket. We're getting there. So x minus 2 to the power of 1 half divided by x plus 1 times, let's clean up the numerator in the numerator. So it's 2 times x minus x is just x, and then 2 times negative 2 is negative 4, and then minus 1, it's negative 5. And down on the bottom, I have x minus 2. So I have a double fraction again. How do I take care of that. Well, let's first copy the first part. Nothing that's being carrying over from one step to the next, and then times. So I can think of the second one as a fraction divided by divide two fractions by multiplying with the reciprocal, or I can go inside with inside, outside with outside, and so that gives us 1 times x minus 5, which is just x minus 5, and down on the bottom I get 2 times x minus 2 to the power of 1/2, and then times the x minus 2 that was already there. And oh, isn't this nice? Look, these two guys cancel out, and all I'm left with is 1 times x minus 5, which is x minus 5, divided by 2 times x plus 1 times x minus 2. So this is it. This is a simplified version of the answer. Now, let me make a note that this was the derivative. So, we could have stopped there, but that was nasty looking. And so we had to do some series algebra to get that looking in its simplest form. And you would probably agree that x minus 5 over 2 times x plus 1 times x minus 2 is much simpler. So this is the simplified form of the answer, and up at the top it is still the derivative, but it's not the simplified version. And that's it, guys. That's where we are.